guys, welcome to Physics Hub. So we are going to discuss another assignment number 2 from the electromagnetic theory. This is from the Unacademy Plus course, whose link is given in the first comment. You can get the course at the first comment, and you can also join our Telegram group from the link given in the first comment, and you will get the PDF. Now guys, if you are new to this channel, please subscribe the channel and don't forget to press the bell icon. Now without any further ado, let's just start assignment number 2. So we have already uploaded 2 videos on assignment number 1. So today we will be discussing the assignment number 2. So let's start with the first problem. This is problem number 1. So the problem reads like this: the electrostatic potential V of xy in the free space in a region where the charge density rho is 0, given by V of xy is equals to this. So you are given the potential expression for e to the power 2x plus f of x minus 3y square, and it is charge free region, means rho is equals to 0. Given that the x component of the electric field Ex and V are 0 at the origin, means at xy is equals to 0, 0. This is given to you. So what is the value of fx? That's what you have to find out. How can you solve this problem? This is very easy. As the charge density is 0, by looking at this, we can say that we can use Laplace equation, grad square V is equals to 0. Now you see, it is given in Cartesian coordinate x and y. So we can easily express grad square V in Cartesian coordinate. How can you express? We can express it in this way: del square V by del x square plus del square V upon del y square is equals to 0. Now V of xy is given to you, so you will find out these quantities, okay, and you will end up getting an expression, and using these boundary conditions you can easily find out the value of fx. And it's a very standard problem. This will give you option D as the correct option. Okay, so I hope you can easily solve this problem. Let's quickly move to the next problem, problem number 2. Let's see what does the problem say. 4 forces are given below in Cartesian spherical polar coordinates. In both the coordinates, mixed forces are given: F1, F2, F3, F4. You can see some of those forces are given in Cartesian coordinates, some of the forces are given in spherical polar coordinates. Where k is a constant, identify the correct option. 3, 4 are consecutive, but 1, 2 are not, and in this way. So basically you have to find out whether the forces are conservative or not. So what is the way to know about whether any force F is conservative or not? So we know that if the curl of that force is 0, then we can say that the force is conservative, and it can be expressed as gradient of some scalar, F minus grad V. So this is the basic rule. So for the given forces F1, F2, F3 and F4, you will take the curl, okay, and whichever forces will give you 0 upon taking the curl, those will be conservative. If it is non-zero, then it is non-conservative. That's it. And in this sorry guys, in this way, if we check all of these forces, you will see option D to be correct, means you will find F1 and F3 to be conservative and F2, F4 are not. So option D will come out to be correct. Let's move to the next problem, problem number 3. It's a very interesting problem. An infinite uniformly charged sheet with surface charge density sigma cuts through a spherical Gaussian surface of radius r. Okay, so here I am doing it. It's a spherical Gaussian surface. So it's अंडा type बन गया, but it is okay. Now a sheet which is carrying a surface charge density sigma cuts through a spherical Gaussian surface of radius r at a distance x. So this distance is x and it has a radius r. That's okay. The electric flux phi through the Gaussian surface is. So how can you solve this particular problem? This is very easy. You see, whenever you will consider the Gaussian surface, you have to consider the charge enclosed. Now for this sheet, only this portion of the sheet is enclosed by the Gaussian surface. The remaining portions are not enclosed. This portion is also carrying some charge sigma, but you see this is not a line, but you can consider like it is a cardboard type thing, like you consider this mobile, so big mobile, so big cardboard you can consider, that is the easier thing to understand. So basically it is nothing but it will appear to be something like some circular like thing. Let's consider a football, and you just slice it by some rectangular cardboard or rectangular let's say some knife, then you will get this thing will look like some circular thing, and this distance is x. Okay, this distance is x. So you have to find out the flux. So what is the formula of flux? How can we evaluate flux? Flux is equals to E dot ds over integration. So flux is equals to q enclosed by epsilon naught. Okay. So what is q enclosed? Q enclosed is the charge enclosed in this portion. Now if this is x, this is r, what will be this value? Root over r square minus x square. Okay. So if this is x, this is r, this becomes root over r square minus x square. So what is the area? Area of the circular portion, it is pi r square formula. Pi into r square is root over r square minus x square whole square, and the surface charge density is sigma. So this will be the charge divided by epsilon naught. Okay. So this will be the flux. So what is the answer? This is matching with option D. You will see it will match with option D. Okay, simple. Let's move to question number 4. We'll be doing it here. What does question number 4 says? A static spherically symmetric charge distribution given by rho of r is equals to a by r e to the power minus kr. A is a constant, k are some positive constant. The electricity potential corresponding to this charge distribution varies with r. So this is very simple. Rho is given to you. So you know the Poisson's equation, grad square v is equals to minus rho by epsilon naught. Okay. Now this is given in spherical polar coordinate. Okay. So what you have to do? If this is given in spherical polar coordinate, you will express this grad square v. This is Laplacian. So you will express it in spherical polar coordinate, and the spherical polar coordinate, and the convenient part is rho is given. You see, only r part is given. So here also only the r part will remain, and that will be 1 by r square. You know it, although I am writing it for you. ddr r square dv dr. This is equals to minus rho by epsilon naught. Rho is given to you. Now after simplification you will easily find out the value of the electrostatic potential. Simple, and you will get option B to be the correct option. Question number 4 is done. Let's move to question number 5. What does question number 5 says? Given a spherically symmetric charge density, rho of r is equals to kr for r less than r, it is 0 outside. Okay. The electric field for r less than r, you can take the total charge to be q. So this is very simple. You can utilize Gauss law. Gauss's law. What is Gauss's law? E dot ds is equals to q enclosed by epsilon naught. Okay. So you have to find out the electric field inside r less than r. So we can consider a Gaussian surface inside the sphere. Okay. So you can express it E into 4 pi r square, and q enclosed you can calculate using this integration of rho d tau, d tau will be, look, it is a function of r only, so d tau you can write 4 pi r square dr, and in this way simply you can find out the value of the electric field, and it will come out to be option B. Okay, so I have given you the hints of these 5 questions. If you think that you need a detailed solution of these questions, you can let me know specifically which solution you want in detail, then I will try to upload a dedicated video by giving you the detailed solution. Although I have tried to give you the hints, and I hope and I think you will be able to solve it, and you can get the PDF of this assignment at our Telegram group, so you can join the Telegram group. The link is given in the description, in the first comment. So this is all for this day, guys. Thank you very much. See you guys in the next video. Bye bye. Unacademy is India's largest online teaching learning platform. You can prepare for various competitive exams like CSIR-NET, GATE, JEST, IIT-JAM, TFR. Especially if you are preparing for CSIR-NET Physical Science, you can join me on Unacademy Plus. I cover all the 9 units of CSIR-NET Physical Science syllabus. My approach is especially I precisely give you the concept of the concerned topic. Then I discuss the relevant mathematical formula and do the analysis. Relevant problem based on the topic, including previous year questions, are discussed. Homework and assignments are also given. This is my profile, and if you want to join my Unacademy Plus courses, you can enroll for this course. And if you are new to this Unacademy platform, you can take Unacademy Plus subscription using our referral code PhysicsHub, and Unacademy will give you 10% off. So take the Unacademy Plus subscription today and put your feet one step ahead towards reaching your goal. Thank you.